Okay, folks, one of the things that we're going to need to review tomorrow is about square roots, and we did this just 2 days ago, okay? And it says to find the square root of a number n, find a number that when multiplied by itself equals n. All right? To find the square root, you can use a calculator, which is what we're going to use, or, like Mr. C back when he was a boy and there was no electricity, you can use a table of squares or square roots on page 671. We're not doing either of those. We're using the calculators that we have provided in front of us. Okay? So, let's practice doing these. Someone find the square root of 121 for me, please. That's going to be Connor. Don't tell me yet. Connor's going to do 16. And let's see, Riley, you do 17 for us. Connor, what'd you get for 16? The square root of 121 is equal to? 11. Beautiful. 11. Riley, the square root of 33.64 is equal to what?
5.8.
5.8. Beautiful. Now, let's just take a moment and estimate what the square root of 17 is. And I'm going to call on somebody to tell me what they think it is about, an estimate. Let's see. Grayson, what do you think it is about? Grayson says about 4.1 or 4.2. That's his guess. And here's why he guessed that. He knows that the square root of 16 is equal to 4 because he knows his times tables. He knows that the square root of 25 is equal to 5. So he knows that the square root of 17 is closer to 16 than it is to 25. So the square root of 17 is closer to 4 than it is to 5. He said 4.1. Okay? Andrew, can you give me an approximation what it says on the calculator for the square root of 17? Can you do that for me?
I have a
Okay, let me ask Sophia. Sophia, can you give me an approximation for the square root of 17 on the calculator? Can you do that for me? And just let me know what you get. .26. Okay? So pretty close to what Grayson had told us at 4.1. Okay? Nice. Okay, and let's look at the last one here for the review. This is what we did last night, the Pythagorean theorem. We're just going to take a moment to do, we'll probably do 2 of these. First thing it says is identify the triangle as acute, right, or obtuse. We'll do that for each one of them first. What about this triangle right here? What do you think, Sydney?
Obtuse.
It's obtuse. Well done. Okay. How about this triangle, number 21? What's that one, Chloe?
That is a right.
It is a right triangle. Good. And Jordan, what about this triangle? It's not an acute triangle. Megan? It's a right triangle because it has a 90-degree angle in it. Okay? They tricked us because they didn't put that little square right there, Jordan. Jerks. All right? Now, it says, if the triangle is a right triangle, find the missing side length. Well, I tell you what, we're not going to do both of these. Let's just do one of them. Let's do this one right here, number 21. Okay? So, what do I use to find that missing side, Vivian?
A squared plus b squared
A squared plus b squared is
is equal to C.
equal to c squared. What's the name of this? Vivian?
Pythagorean theorem.
Pythagorean theorem. Vivian, what do I put in place for A?
10.
Good, 10 squared. What about B? 24 squared. That's the 2 legs. You're looking for c squared. 10 squared is 100. Anybody have what 24 squared is? What do you think 24 squared is, Sydney? I think it's 576. I'm guessing though. Can someone check that for me? 24 times 24 is 576. Is that right? Good. And that's going to give me 676 is c squared. Now what's the square root of 676?